Welcome back. Let us see more traversal technique. In the previous video, we have seen a traversal technique called in order. In this video, we are going to see another technique called pre-order traversal technique. So let us see how does it work. So pre-order is slightly different from in order, where you are going to visit the node first. Then you are going to visit the left subtree. After visiting the left subtree, you are going to visit the right subtree. So the order is going to be the root, we take it as node. Then you have to visit the left subtree. Once it is completed, you can visit the right subtree. So please do remember the order for this is going to be N, L, R. N stands for the root, L stands for the left subtree, and R stands for the right subtree. Right? So please do remember which is going to be N, L, R. So let me repeat. First visit the root, then you have to visit the left subtree. Once it is done, you have to visit the right subtree, but make sure that the right and left subtree are visited in pre-order. Those trees also you have to visit in a pre-order fashion. Okay, so let us see the actual fact for this. So if you take the given diagram, it says you have to visit the root node. So root is going to be 1, so you can write the order is going to be 1. Then visit all the nodes in the left subtree. So you have to visit 2. But what happened when we visit the left subtree? Make sure that even for the left subtree you are going to visit in pre-order. So first you have to visit root, which is 2. Then you have to visit the left for this, which is 4. So you have to visit 2, then we have to visit 4. Once it is done, you have to go with the right subtree for this. So right is going to be 5. That means you have visited successfully 1, which is the root. Then you have visit nodes in the left subtree. Which is the left subtree for this? Which is 2, 4 and 5. So we are done with the first two statement. Once it is done, visit all the nodes in the right subtree. So when I say all the nodes in the right subtree, I'm talking for the node, I'm talking about the root node, and for the root node, you have to visit the right subtree. So for the root node, we have got a single node which is 3. So in fact, what happened? We have successfully visited all the nodes in the given binary tree in the form of pre-order. So what is the sequence? The sequence is going to be 1, 2, 4, 5 and 3. Okay. So let us take a small algorithm for this and we'll trace it. How does it works actually? So please take more interest, have more patience, and trace along with me. So this is going to be very crucial because whatever the piece of code we are writing, that piece of code you have to write recursively. Okay, so let us see the actual piece of code. So it's hardly 5 to 6 lines. So this is the thing which is going to visit the given tree in the form of pre-order. So as I told, which takes a single parameter ptr. So I've taken a tree with 1, 2, 3, 4, 5 nodes, and I just converted this into a linked format. So this is my first node, second, third, 4 and 5. Now what is this PTR we are talking about? This PTR gets address of the first node. So what I do is I'll take a variable called PTR. So let me write this is going to be the PTR. And what is PTR? PTR gets address of the first node. What is the address of first node, which is 10? So for this statement, for this recursive function, PTR is 10. Now what it says, Look at the next statement. If PTR, that means PTR is not a null value. That means there is a tree which is in place. Tree is not empty. If tree is not empty, we cannot visit the tree. So you have to check it out. Is there any tree which is really existing? If it is true, we can. What you do is you are going to print percentage D will be replaced with PTR data. Look at this. What is your PTR? PTR is the address of the first node. And for the first node, what is the data? Data is going to be 1. So you are going to print or you are going to visit the first node. Once it is done, you are going to call the same function PTR left child. So what is PTR? PTR is a pointer to the first node. This is a PTR. Now PTR is going to change its value. So PTR is going to change its value from the first node to its left child, so which is going to be 20, right? So here it is 20. So we call the same function with different address. So let us take this as the second function. Before PTR has got value 10. Now in this case the PTR is getting value as 20. And what does it mean? Now PTR is a pointer to the second node. So PTR is a pointer to this. So let me erase the first one where PTR was a pointer to the first node. So we are done with this. Now what it says, if PTR, if there is a left subtree existing for this, if it is true, so PTR data, so you have to print the data for this. And what is the data for this node? Which is 2. So you are going to print 2 now. Already we have printed 1. So we are going to print 2. Again, pre-order PTR left child. PTR left child. So PTR will point to the next node. What is the value for this? Value for this is going to be 40. Before it was 20. Now this is going to be 40. So let me write it as 40. So we are here. So pre-order. So function calls itself, which is a recursive function. We'll come to this. So here it is going to be 40. Check if PTR, whether PTR has got some value. Yes, it's true. So what it says, PTR data. So you are going to print what is the data part for this. What is the data part for this, which is 4. We are going to print this. Then pre-order PTR left child. So PTR is a pointer to this, and what is the left child for this, which is null. So 0. So what happened? So pre-order 3 pointer, what is PTR in this case, which is 0. If it is 0, you cannot enter this loop. If PTR is true, you can do whatever is within the if statement. So you are going to come out of this. So where this function is going to return? So this function is being called by its previous one. So it will return back to the calling function. So it will start with the pre-order PTR right child. So where is PTR now for this function? PTR is 40. So we are talking about this. So let us erase all other things. So let me erase all other things. Yeah. So PTR is pointing to the node which is having address 40. We are talking about this. Then pre-order PTR left child is done. PTR right child. So what is the right child for this? Again, this is 0. So again it will go to the same function, and PTR is going to be 0. If it is 0, we cannot do with this function. So this function will be returned to its previous function. What it says? Pre-order PTR right child. Where is PTR now? PTR is having an address 20 here. Now PTR is a pointer to the previous node. This is PTR. Right? So what it says? Pre-order PTR right child. So what happens? What is the right child for this? Right child for this is going to be 50. So I'll take another function where I'll mark PTR as 50. So if PTR, so let me erase all other function. So now what is my PTR?